Hi everyone. Today is an important day. We're going to determine the shortest distance from a point to a line. This is a fairly involved process. A bunch of steps are involved, so hopefully you'll be able to get used to doing this, kind of figure out the process. So we're going to work through the problem that's shown here. You should have this handout in front of you. And of course, the first thing we would do is we would plot the information that we have. And there you go. And without doing any calculations or anything else, maybe it's worth actually drawing in what I think the altitude looks like. So I know the altitude has to come from C because that's part of the question. And I know as an altitude, it has to go directly, and by directly I mean at a perpendicular angle. Right? It has to meet the other side at a right angle. So I'm just going to draw in what I think it might look like, maybe something like this. And even if it's not totally accurate, that's a pretty good place to start. So I want to think about what this question is asking me. It's asking me for the length of my altitude, the length from here to here. How far is it from there to there? Well, my length formula will tell me if I have two endpoints. So looks like what I really need is, well, I've got this endpoint, so I need this point here. I mean, I can see that what it kind of is, but I need to know exactly what that point is. And so I need to kind of think backwards. Well, I'm even going to name that point already. It's an intersection point between these two things, so I'm going to call it x. So what is x? Well, x is actually the intersection between two lines. It's an intersection between this line, and it's an intersection between this line, right? If I want to know what x is the intersection, the point of intersection. It is the solution to the linear system made out of this line and this line. And so fortunately, we spent a whole unit figuring out the solutions to linear systems. So let's take a second here and just list, what is it that we all need to know? Well, like we said, we need to know this point here because we need the length. So let's start with the fact that we need the length, right? We need the length of CX, right? Well, in order to figure out the length of CX, we're going to need x as a coordinate, right? And in order to figure out that, we decided that x is the intersection of two lines, and we'll call the two lines CX, I guess, and AB. Now, AB, I think already we could figure out, we have a point here and a point here that we know, and we can figure out a y equals mx plus b solution for that, or an equation for that equals mx plus b. That will be fine because we can calculate slope and then sub in. But the line CX, can we figure out an equation for that? Well, we've got a point. Do we have a slope? Not really, because we don't have 2 points for a slope, but we do know that this slope, the slope of CX, is perpendicular to the slope of AB. So the slope of CX is perpendicular to the slope of AB. And that's information that we can use to come up with an equation, y equals mx plus b, for the line CX. All right, so if we can get ourselves organized here, we can make some room and start attacking this problem. And so since this is the list of things that we need, let's start working our way backwards. We're going to start by finding the equation of line AB. Well, we need the slope of AB first, and y2 minus y1 is negative 2 minus 4, x2 minus x1, 12 minus negative 8, negative 5 over 20 looks like, so that looks like negative a quarter. Great. Y equals mx plus b. We're going to sub in the slope first, or we're going to put in the slope, negative 1 quarter x plus b, and then we will sub in point b, I guess, doesn't matter if it's a or b, we'll put in b, which is negative 8, 4. Here we go. 4 equals negative 1 quarter times negative 8 plus b. And so 4 equals, let's see, a quarter of 8 is 2. plus b looks like 2 equals b. So therefore, y equals negative 1/4 x plus 2. Always, I do a little check. Does it look like that this line that goes through about 2? My line is close. I might not be totally accurate. Yeah, it looks like this is a little bit low from 4. So I think that's reasonable. So let's call that the line for AB. So let's put that, I suppose, over here. That AB is y equals negative 1/4 x plus 2. Great. So if we get that information out of the way, then we can call this done. And we need the slope, or we need an equation of this line, cx. Why do we need the equation of this? Because x is the point that we want, and x is the intersection of that line and that line. Okay, so line cx. What do we know about line cx? Well, we said that we can get the slope from the fact that it is perpendicular to line BA, or line AB. So we're going to write something to that effect. We know that the slope of CX is perpendicular to the slope of AB, right? Therefore, the slope of CX is 4, or 4 over 1. And we will put that in right away. Y equals 4x plus b. To find our equation, we will sub in the only point we can, which is c, to negative 7. Here we go. Negative 7 equals 4 times 2 plus b. Negative 7 equals 8 plus b. It looks like b must equal negative 15. And again, well, I can finish off by writing the equation. Y equals 4x plus, minus 15. And I'll just double check. Does this minus 15 make sense? If I were to extend this line all the way down, could it be made an argument that that would cross at negative 15? Yeah, that's kind of reasonable. So I will record the fact that Cx is y equals 4x minus 15. There is part number 2 finished. Now, let's just get that out of the way and look at my list here. Okay, so I've got that equation, I've got the equation. I need to find the intersection of these two. I want to find what is that coordinate for x. So I'm going to set up my system of equations, right? Linear system. Negative 1/4 x plus 2, and cx, y equals 4x minus 15. And when I have two things that equal y, I'm just going to sub AB into cx. Here we go. Negative 1/4 x plus 2 equals 4x minus 15. Now, because I don't like fractions, I'm going to multiply everything by on both sides by 4, right? And that'll eliminate my fractions. And if I do that, I get negative 1x plus 8 equals 16x minus 60. And I will continue. Moving my x's to one side, subtract 16 from both sides, I get that negative 17x equals, let's see, negative 68. And divide both sides by negative 17, and I think x works out nicely to 4. And so then I will sub x equals 4 into one of my equations. I'm just going to use the one that doesn't have fractions. That might make it a little easier. So sub in 4 right here, minus 15, 16 minus 15, and y equals 1. So it looks like x must be 4, 1. And once again, I've got an answer. Check my diagram. That looks about like 4, 1. So I'll fill in my coordinate where I need it, right here. X is 4, 1. Can fill it in here and call that checked. And I have one thing left to do, to find the length that I was instructed to find. And here we go. Using the equation of for length of cx is the square root of, well, let's just do it, x2 minus x1 squared plus y2 minus y1 squared. Let's sub in big long square root of, let's see, x2, 2 minus 4 squared plus negative 7 minus 1 squared That looks like negative 2 squared and negative 8 squared. Negative 2 squared is 4 and 8 squared is 64. Looks like the length of CX equals exactly the square root of 68. Some of your smart calculators might say that it's exactly 2 root 17. Either way is fine. And the length of CX is approximately, let's see, root 17 times 2. Looks like it's about 8.25. Usually I go to 2 decimal places. And so, therefore, the length of the altitude from C is about 8.25. And we eyeball it. Does it look about right? Well, let's see. From there to there, if I was to go exactly straight up, that's about 8. Could that be about 8? Sure, that's reasonable to me. So, we will just continue on because there's a second part to the question. We've done the big thing, and this is finding the distance from a point to a line, right? And that's generally find the equation of the line that we're going to, find the equation of the line from the point to the line using the perpendicular slope, setting up a linear system, finding the intersection, and then determining the length. So to recap, I would say that the steps that we took were number 1, to find the equation of the line we're going to. Number 2, to find the equation of the line that's from the point to the line we're going to, right? And use the perpendicular slope when we do that. Number 3, use the linear system to find the point of intersection. I usually call that X. And number 4 is determine length from the point that we're coming from to that point of intersection. The second part of the original instructions that we were given was to find the area of triangle ABC, right? And that isn't so hard because we know, first of all, that the area of a triangle is half times base times height, right? You might know it as base times height divided by 2. And an altitude, if you remember, is of course a height, so it looks like we have a height, and if that's the height, then of course this would be the base, right? And so in the case that we're looking at, I would argue that the base is line AB, and the height in this case is CX, right? And really it's the length of those things. So the area of ABC, I would argue, is, well, it's half times the base, which is going to be then the length of AB times the length of CX. Length of CX I already have from the last question, and I said it was approximately 8.25. And I said it was exactly the square root of 68. Now, I like using exact numbers. If I was to use this rounded off number, it's actually going to throw off these calculations. Anytime you reuse a number that's been rounded in your next calculation, you know your final answer can't be very accurate because you've used a number that's not exact. So I'm going to choose to use this the square root of 68. I need, in order to finish this off, I need the length of AB, and length formula is easy as long as I have 2 points, which I do. And so let's go ahead. x2 minus x1, we'll call that 12 minus negative 8 squared, and add that to y2 minus y1, so we'll call that negative 1 minus 4 squared. And we'll work this out. Let's see, 12 plus 8 is 20 squared. And negative 1 minus 4 is negative 5 squared. And that is 400. And this is 25. It's still in the square root. Equals the square root of 425. Now, that can equal something. I don't even really care too deeply about approximately what square root of 425 is, because all I'm going to do is sub that in to the area of ABC, and it's half times the square root of 425 times the square root of 68. And when I punch that right into my calculator, 0.5 times 425 square root, looks kind of messy, times 68 square root equals, my calculator actually spits out a beautiful whole number that the area of ABC is exactly 85, I guess we call them square units. So if I had subbed in a decimal number, an approximate decimal number, if I had made this into an approximate decimal number and I had subbed them in here, I would have got an answer that was close to 85, but not exact. Here's a case where using exact values spits out one exact whole value, which is the correct answer. So there you have it. Finding the length, the distance from a point to a line, right? Which is said another way when it's in a triangle, finding the length of an altitude. This is a pretty major calculation that you have to do. It has multi-steps, and so it's unfortunately lots of places to make a mistake, but this is kind of the big thing from this unit, so you're going to practice this lots, and you're going to get really great at it. All right, good luck.